Hi everyone. We are right at 12 o'clock. I'm going to open the chat just so I can see if anything pops up. Can everybody hear me okay? All right, all right. So feel free to use your reacts to, if something is off, you can't hear me, or, you know, shoot me a thumbs down or something if I if you can't hear me at all or internet cuts out, I guess I wouldn't notice, but oh, thank you. Okay. So, thanks everybody for joining today. I really appreciate you taking the time out of your busy days to hop in and listen to our harmful algal bloom lunch and learn. My name is Susanna Harris. I work for the Pennsylvania Department of Environmental Protection, as the Great Lakes Restoration Initiative Program Coordinator. My colleague, Amber Stillwell, is today's presenter. She works for Pennsylvania Sea Grant as the Lake Erie office's coastal outreach specialist. She also serves as Penn State Extension's Master Watershed Steward Coordinator for Erie, Crawford, and Warren counties. We hope that today's webinar will provide you all with some necessary information to stay informed about and prepared for harmful algal blooms in our waterways. Thank you, Amber. We're really looking forward to your presentation, and I'd like to turn it over to you now.
Thanks, Susanna. I really appreciate the introduction. And I'm looking forward to today's presentation as well. And I forgot to tell you that I made a Meet Your Presentation Team slide.
Oh, great.
So Susanna forgot to mention that she is the current chair of the Pennsylvania Lake Erie Harmful Algal Bloom Task Force. And she is doing a wonderful job leading that charge, which I will also talk about next. I don't want to forget, though, that we also have our aquatic invasive species intern online today, Sophia Krasinski. She is helping in the background. So, Sophia, thank you for being here today and spending your time with us.
Hi, thanks for having me. Happy to help.
Awesome. So before I get started, just a little bit about the Pennsylvania Lake Erie HAB Task Force. If you have not heard of us, this is a task force that was involved, or it came to fruition in about 2013 when harmful algal bloom issues started to get really, really big and popular in Lake Erie. And if you all remember, the Toledo water crisis occurred in 2013, and we were actually already doing some harmful algal bloom testing and monitoring at that time. So when that happened, we were already well prepared in Erie for something like that to occur. And the effort has just grown over time, and the purpose has evolved to create a unified approach to monitor for harmful algal blooms and their toxins and provide this information directly to resource managers and the public at large in a timely fashion. And so I want everyone on the call today to just realize that Erie PA is special in this team that we have developed. There is also a Pennsylvania DEP-led statewide harmful algal bloom task force. And I'm involved in both task forces, and I'm really happy that Pennsylvania is working on the forefront of these harmful algal bloom issues. Erie, although I'll get back to what I was saying about Erie, Erie is special. The Regional Science Consortium, one of the partnering members of this task force, brings in 100% grant funding to fund their monitoring and testing of harmful algal blooms in Erie, PA. So it is a really, really concerted effort to protect the population of people that visit Presque Isle State Park every year, which is upwards of 1 million visitors a year, which can be more than Yellowstone National Park even gets. So keep that in mind. It's all grant funded, and it's really important to maintain that funding stream as we move forward with many of these important issues. That being said, we have other agency members. So obviously DEP with Susanna, the chair at the helm of the task force, the Department of Conservation and Natural Resources, or Pennsylvania DCNR, the Erie County Department of Health. These are our agency members. And then we also have our partnering members like Regional Science Consortium, Pennsylvania Sea Grant, and additional partners include the Erie Waterworks, the Northeast Drinking Water Authority, and the Erie County Conservation District. So it's a wonderful group of people that work together really, really well to create a lot of the information and procedures and monitoring types of skills that I am going to present to you today. So before I dive into the agenda for the day, I just want to give you a brief background about Pennsylvania Sea Grant. So we have the three legs of Pennsylvania Sea Grant's pigmented stool, and those are research, outreach, and education. And our overall mission is to promote the sustainability of Pennsylvania's ecological and economic coastal and watershed resources through science-based research, education, and outreach. So our goal is really to take what people are learning at the researcher level and also hopefully deliver funding to the researchers that are doing this type of research, and then extend that information to the communities that need it, whether that be outreach like this presentation today to you all that are interested in learning about harmful algal blooms and water quality, or creating educational opportunities for K through 12 teachers so that they can extend this knowledge to their classrooms. And if you are a teacher, whether you're a formal teacher or a non-formal teacher, we do have a harmful algal bloom Great Lakes literacy education opportunity, and it's available online. It's a virtual classroom that you can go through in order to learn how to teach about this in your classroom and gain skills and materials to do so. So that being said, let's dive into today's agenda. And what we're going to talk about is all harmful algal blooms, right? But we're going to dive into HABs 101. So just a basic overview of what harmful algal blooms are. Then we're going to dive into the meat and potatoes of identification. And I hope that you all walk away with skills to identify what is and is not a harmful algal bloom in order to keep yourselves and your family members and your beloved pets safe this summer. We'll talk a little bit about prevention towards the end of the presentation. I'll just touch briefly on management, but please note that I am not a management specialist, so likely I will not be able to answer many questions about management today. But I can maybe possibly point you in a direction for some assistance if needed. And then I'm going to deliver to you a ton of resources where you can find more information. And before we jump into HABs 101, please use the chat function and the Q&A box for this webinar. So if you have questions for us, please type them in the Q&A. That way they don't get lost in the chat, because when we get to the identification portion, I'm going to ask you to put in the chat a bunch of yeses and nos. So please just be aware that if you ask questions in the chat, they may get lost. All right, let's go. HABs 101. So cyanobacteria and harmful algae, these two terms are often used synonymously. But when we break it down, harmful algal blooms, or HABs, occur when cyanobacteria are blooming in excess and they're producing those harmful toxins. So the HABs that we think of, another name of them is blue-green algae. They're actually a cyanobacteria. So this is a complicated mix-up in scientific naming, where, something that has been on this planet older than dinosaurs was mislabeled as algae because it completes photosynthesis, but it's actually a bacteria that completes photosynthesis. It's an incredible organism. It does produce those dangerous toxins, though, that make it a concern for people and animals. So algae and bacteria, it's important to remember, are producers. They are food sources in aquatic environments. They are natural, including cyanobacteria. They're not an invasive species. They're not introduced from somewhere else. They have always existed all over the planet, including in freshwater bodies. Now, when excessive growth occurs, they lead to these blooms. We call them blooms because they're visible on the surface of the water. Then, when those blooms are occurring, then they can create those human and environmental health concerns that we all, hear about all summer long. So let's dig a little bit into what forms those blooms. Why do they happen? Well, it's typically created by the perfect storm. So nutrients in the water are typically the limiting factor. We have to have excessive nitrogen and phosphorus in the water in order for these organisms to start blooming out of control and to start producing their toxins. However, they also have preferred um, weather conditions, just like anybody else. You prefer to go to the beach on a day that it is hot and sunny and there's very little wind. However, sometimes you might go to the beach when it's raining just to see what it looks like. So even if you have, um, you know, the raining kind of cooler temperatures, you can still have a harmful algal bloom occur. But more than likely, you're going to have this perfect storm occur where there's excessive nutrients in the water. The temperatures are high, so it's hot both in the air and in the water. And then there's lots and lots of sunlight. So the nutrients seem to be that driving factor. So keep in mind that, we can't control the temperature around us. We can't control the amount of sunlight, but there are things that we as humans can do to prevent excessive nutrients from getting into the water and creating harmful algal blooms. So we're going to talk about those at the end of today's presentation. Um, Additional considerations. So these are really just things that I noticed doing this work for over a decade in Erie. We are having heavier than usual rains that are followed by really intensely hot weather. And we are also having longer lasting summers and growing seasons. So these two things combined, whether you look at it from a long-term scale of whether or not it is a factor of changing weather patterns, or if it's just, something that's occurring this summer, however you want to look at it, when we have these conditions, heavier than usual rains, followed by intensely hot weather over a long period of time, these seem to factor into having harmful algal blooms that are more persistent and more toxic. In at least the Erie area. Now, someone asked me a great question about this prior to this webinar. And so what I encourage you to do is to get to know your lake or pond and see if you can notice any of these types of trends. They may not be the same as they are in Lake Erie. So keep that in mind. So the cyanotoxins are really what is the biggest concern with harmful algal blooms because they are produced under the right conditions with those high nutrient levels, an excessive amount of light and a warm temperature, and even sometimes high humidity can be a trigger. And they are what cause the health effects that can be very minimal to even sometimes life-threatening. So in people, we are usually going to see minimal health effects, things like headaches, diarrhea, and skin irritation or rashes. In canines and other wildlife and livestock, we are more concerned with some of those more life-threatening symptoms like seizures that can lead to the death of the animal. And the most measured toxins in the United States, so the most reported, are microcystins, cylindrospermopsins, anatoxins and guanotoxins, saxitoxins, and nodularins. You don't need to know what all of these toxins are. My point here is that these toxins are simply a chemical that is being excreted from the harmful algal bloom. Or in some cases, the cell of the bacteria is holding the toxin in place. And when, for whatever reason, that algal or bacteria cell is burst or dies, then it can release the toxin into the water as well. So the cyanotoxins are produced from the cyanobacteria, and this is what causes that algal bloom or that bloom to become harmful. It's also important to remember that many different types of cyanobacteria can release different types of toxins. And this is kind of where things start to get a little confusing. And this is why I think it's more important for you to be able to identify that you have a HAB in front of you instead of being able to get down to the nitty gritty and know which type of bacteria you're dealing with, because they all produce multiple toxins that could be harmful. And actually, I shouldn't say all, because some cyanobacteria don't produce any harmful toxins. However, if you have them blooming out of control, they are likely going to be producing something that you don't want to step into. So if you look at my chart here, you can see the cyanobacteria microcystis, which is one of the most common ones that we have here in Pennsylvania, it will produce a dermatoxin, meaning that it will give you a skin rash, and also a hepatotoxin, and that means a liver toxin. And so that means that at certain levels, if you consume water with the toxin in it, that's going to hurt your liver. And then other cases, we have something like Dolichospermum, which, if you're familiar, it was formerly called Anabaena. That's the cyanobacteria species, and it can produce a dermatoxin, a liver toxin, and two different neurotoxins. So it's really just important to understand that the different cyanobacteria can produce different types of toxins that can cause those harmful health effects that we were talking about earlier. And a lot of questions come up when we think about the long-term health effects of exposure, like chronic exposure to cyanobacteria. Um, there is evidence to link microcystin, the toxin, to liver and colorectal cancers, but there's not enough information to actually assess the carcinogenic potential. So what that essentially means is that there might be a case here, there might be a causation, but we don't have enough data to prove it yet. And there's also insufficient information at this point to link the other toxins I mentioned to as carcinogenic. So just something to consider. Like, scientists aren't saying no, but they're not saying yes. And it's really, really difficult to determine causation when you're talking about carcinogens because they have to be present and we have to have a lot of studies done. Bioaccumulation is a little bit different. There is sufficient evidence to show that microcystins, cylindrospermopsins, and other toxins can bioaccumulate in aquatic vertebrates and invertebrates. So things like stoneflies, like you see in this photo, they can, bioaccumulate some of these toxins, and then they are eaten by larger animals like fish. And then this could possibly translate to bioaccumulation into the food chain. So this could pose a commercial threat to recreational fishing industries, or sorry, it could pose a monetary threat to commercial and recreational fishing industries, which in Pennsylvania are valued at over $4.5 billion. So just something to consider as an economic impact of harmful algal blooms. This is not the only one, and I could probably do an entirely different presentation on the economic impacts of harmful algal blooms, but this is the one that I wanted to feature today. So thinking about those health risks, I mentioned that canines are at higher risk of exposure. So something to note, I am not a veterinarian. I am not trained in medical or veterinarian sciences. This is information. I have a list of resources that I pulled at the end of the presentation. So this is where I'm getting the information from the Department of Health in Pennsylvania and the CDC and multiple other organizations. But always act upon your own best interest and your pet's best interest when you take these things into consideration. The research shows that canines are at a higher risk of exposure because they interact with the water differently. They are going out into water and they're just drinking it. Some dogs will drink any water. Some dogs are a little bit more picky, but they're more likely to directly consume water. Whereas when people are out playing in water, even young children, they're not usually purposely drinking the surface water. And what this means is that the animal is getting a more direct dose of whatever is in that water, whether it be E. coli bacteria, which comes from the fecal material of animals, or it could be those cyanobacteria toxins. And when we think about how humans are affected by harmful algal blooms, human poisonings from cyanotoxins are extremely rare, but we still should be cautious. We don't know what those effects of chronic exposure are, whether that's cancer or Alzheimer's or anything like that. We just don't know. So we should still be very cautious. And children are more easily affected simply because their body mass is much smaller than ours. So if a 3-year-old child is playing in water and consumes, an accidental, thimble's worth of water, that's going to affect a child's body much differently than it's going to affect an adult's body because we weigh different. And that's simply just how toxicity testing works. So all this being said, prevention is the best avenue for avoiding this kind of exposure, preventing exposure and raising awareness, which is what we're trying to do here today. But just in case you are exposed to a harmful algal bloom, or say you are visiting a place that posts signs, which not all places do, but if like we've had this happen on Presque Isle State Park before, where people will enter the water, they'll come out of the water with their dog, and they'll be like, "Oh my gosh, there's a sign posted for harmful algal blooms. I didn't even notice." And they'll call and say, "What do I do?" Well, this is what you do. You observe your animal, or your child, or yourself, whoever has been exposed, and you just see if they start to act funny. They might, start to throw up consistently, or like start walking in circles. If you notice any weird behavior, seek immediate veterinary care or call a poison hotline to see what you should do next. For canines, there are treatments that exist at veterinary offices, but they're quite expensive. And the longer you wait, the longer that expense is going to be. And the outlook, even still, for a dog that has been exposed and is showing symptoms is often not very good. So if they go untreated, then the toxin exposures in canines are usually fatal. And like I said, even if they do receive care, the outcome might not necessarily be what you hope for. So that's why prevention is key. And for humans, no treatments currently exist for cyanotoxin poisonings because they're so rare. We don't really have treatments for them. However, medical professionals can help you manage symptoms if you feel that it's necessary. You can also call poison control, and you can call a healthcare provider. Thinking about health effects and what the research is showing us. So there are very, very few epidemiological studies of recreational exposures for people and HABs. There's a lot more examples of animal exposures, mostly dogs. There are some studies that have been completed on laboratory animals, and there are reports of extreme human exposure, but those, like I said before, are extremely, extremely rare. However, the long-term health effects of chronic exposure are still being studied and remain unclear. And so all this being said, let's try to prevent these exposures by taking a couple extra steps when we're recreating during harmful algal bloom peak season, which is essentially now until mid-October. So this is just a short list of things that you can do to help prevent your exposure and stay safe. So avoid water that appears to be discolored and has visible scums or mats, which after today, you'll walk away as an expert to identify a surface scum. You'll want to follow posted advisories, even if the water looks clear. So the thing that's tricky about harmful algal blooms is that they can control their own buoyancy or their ability to move up and down in the water column. And because of that, say you have a big bloom that's occurring, and then all of a sudden it gets really cloudy. Then the harmful algal blooms or the cyanobacteria themselves could start to sink down, but their toxins are still hanging in the water. So there's now no visual indicator that they're present. So follow those posted advisories if you, even if the water looks just fine. That means that there has been a recent harmful algal bloom and they haven't cleared the water yet, or that means that there's a current harmful algal bloom and it's ongoing, just maybe you can't see it. If you do see a suspected bloom, definitely keep your pets away from it and your children away just to prevent their exposure so that nothing bad happens. Err on the side of caution. Rinse off after with clean water after swimming or other water activities. This is just a general, good idea, no matter what time of year it is. If you've been swimming in surface water, that's exposed, there could be a lot of things in it. So it's just better to rinse off, if there's a beach shower, or you can get home and do a quick shower or hose off in in your yard, whatever it is, then it's just a good basic practice. Consider checking for historic conditions. So Pennsylvania DEP has a harmful algal bloom dashboard, which I'll drop in the chat. later, oh wait, I actually might be able to copy and paste it now. Um, this dashboard does not give you updated real-time results. However, it gives you historic conditions. So if you are planning to go to a state park or your local lake and you see that on the dashboard they have a history of harmful algal blooms, it can give you a little hint to say, okay, I should be more cautious because this location has a history of harmful algal blooms, and they could have one while I'm there. It gives you an idea that it could happen. So be more cautious. And, plan ahead. So contact local park managers and health departments to ask about current conditions. Keep in mind that this is not a requirement to test across the state. So they might not have information for you, but if they do, they'll share it. So it never hurts to call. And then, you might get into a great conversation about where you should go swimming and the best places to see while you're there. So just things to consider before you go recreating this summer. All right, let's get into the identification component, which is one of my favorite parts. Um, so the system that we have in place in Erie is really intense for toxin detection. And I'm going to walk you through those steps. And then we're going to practice these first two components, visual assessment, and I will teach you how to do a physical assessment. So this toxin detection is complex, and truly the only way to confirm that you have toxins present is to chemically test. However, there are some tips and tricks that I can provide you today. So let's talk about visual verification first. So this is kind of our first line of monitoring. So if somebody were to call and say, we think we see a HAB, we might go out and say, okay, you do or don't have one based on the visual verification. We know that it's not cyanobacteria, it's not a HAB if there are leaf-like structures or roots in the material, if the material forms long stringy mats that can be lifted up from the water with a stick or your hand if you wear gloves, of course. And if the material is firmly attached to rocks, plants, or the lake bottom. So here's some examples. What we have here are a few different lookalikes that I've gotten calls about in the past. This is duckweed right here, all the way to the left side of the screen. You can see it has tiny leaves and roots that extend out into the water. So this is an up close duckweed. This middle picture is a duckweed infestation or duckweed bloom. They also bloom with high nutrients, so it's a little bit difficult to sometimes tell what you're dealing with. But if you look closely, you can see that it's granulated. It looks like tiny green pieces of rice laying on the surface of the water. So harmful algal blooms will not look like that. This photo here is a picture of a nuisance algae called Cladophora. This is a macroalgae that grows in stringy mats, and you can see it's attached to some rocks. There's water flowing over it instead of the water moving it around. You could pick this up with a stick. So we call that a stick test. You can literally stick a stick in the water and lift it up and pull the material up out of the water, and it'll come up as a stringy mat. Now, cyanobacteria looks very, very different. The stick test fails, right? So the material will consist of teeny tiny particles about the size of a pinhead or smaller, if you can even see them individually with your naked eye. It will form a surface scum or collect along the shoreline. Typically, what happens on larger bodies of water is you have a surface scum that forms out in the body of water in the deeper portions and then is moved to the edge by wind and wave action. And that's what causes these streaky looking appearances. The water will typically appear unusually discolored. So something bright green or gray or white or even milky looking. And so you can see here the teeny tiny particles here. And this is actually a really great example of something we call a float test, which I'm going to talk about next. So keep this photo in mind. And then this is the very stereotypical, like heavy duty harmful algal bloom experience. You've stuck your hand in the water, wearing a glove as always, and it comes out of the water looking like you have paint on your hand, not in stringy rooting forms. So the visual assessment, okay, occurs, right? So say you have you've determined that it is likely cyanobacteria based on your visual assessment. So oops, these photos, go back, these ones. You've determined, yes, I think it's a cyanobacteria. I think it's a HAB. What do we do next? So what you can do to be sure that it's cyanobacteria is to do what we call that float test. So the cyanobacteria, like I mentioned before, can regulate their buoyancy, meaning that they float to the surface of the water when the water is calm. And most algae and bacteria don't have this ability. So any debris and plant material will sink to the bottom, and microscopic animals that are in your sample will swim around randomly. And what you'll end up seeing is if you shake that test, that's just, go out and take a water bottle out and scoop some water, shake it up, wait 15 to 30 minutes. And what you'll see is this ring of cyanobacteria beginning to form at the top. And then you can confirm, okay, I've got some cyanobacteria in my water sample. The only downside is that you don't know what type of cyanobacteria you have unless you identify it using a microscope. So I've been talking a lot about gloves. Just always be cautious and wear that personal protective equipment. And this is not something that I just have to say. It is an absolute safety issue. We have had people, have very brief exposures going out to sample water, put their arms in the water, and come back, get to the lab, and they're like, oh, I have a rash on my arms. How did that happen? Like, go wash your arms with soap and water. You'll be okay. So it does happen. But if you are exposed, you can wash your arms thoroughly with warm soap or warm water and soap after that sampling occurs, and the rash will dissipate. Just be cautious. It's always better to be cautious just in case. All right, so skipping onto the microscopic assessment. So this is something that you can get additional training to do, and I do have resources that will help walk you through this, but I'm going to tell you it's probably not super necessary. If you have a cyanobacteria confirmed using that float test, if it's blooming to such a capacity where you can see it on the top of the water, it is likely going to be producing some type of toxin. Either that or the cells themselves can be a skin irritant. So it's still not something that you want to step into or let your dogs or your children play in. But that being said, in our steps in the process of monitoring, microscopic assessment is really important to us because we want to know what type of cyanobacteria we're dealing with so that we can figure out what type of toxin we could potentially be dealing with. So we would check this under the microscope and try to figure out the species of cyanobacteria, which you see multiple listed on the screen here. So then the steps in our process would be, okay, is it a species that can produce potentially harmful toxins? Yes or no? If it's yes, which it likely usually is, then we move on to the chemical assessment, which in our protocol, and this is the Regional Science Consortium, where they come into play, they have the ability to run what's called an enzyme-linked immunosorbent assay, or ELISA test for short. It takes 3 to 4 hours with basic lab skills, but it does require a specific type of equipment called a microplate UV reader. And that can tell us what type of toxin and in what levels. There are also things that called rapid test strips that are field friendly. They give you results in less than 1 hour, but their limitations are pretty hefty. Their detection limits are not as good. So they're best for kind of doing that screening process and doing an on-site decision making. Like, yes, we have a HAB. You get a result in an hour. You can post a sign or however that process works. Keep in mind, these chemical assessments are not always accessible or affordable. So my tips and tricks for you are to think about how your water body is used. So recreational use advisory thresholds that we abide by for our protocol are listed here, but you'll notice that there are also cell counts here. And we also have dog use advisories. So let me just click through here. Noticing these cell counts here, If you have 100,000 cells per milliliter of water, the water is going to look green or discolored. That means you have a scum present. So what you can say here is, okay, we have a scum, then we need to post or consider an avoid contact advisory. Now, if you are just like going to recreate and you're not managing a body of water, this is a sign for you to say, oh, there's a scum present. I should avoid contact. So just keep that in mind. Also keep in mind the difference in, recreational use for humans versus dogs. The human use is much higher because again, dogs, when they are exposed to something like this, they're swallowing a lot more of that water. So their potential for exposure is greater. That's why the dosage is lower for them to be exposed. Also keep in mind that recreational use is different than drinking water use. So in our drinking water, the rules would be much, much more strict. And they would be, I guess, strict as in the thresholds would be lower because you'd be directly drinking that water. All right, so before we get to our identification exercise, this is that Pennsylvania HAB dashboard that I mentioned. And I'll skip to the next slide, which is how to report a HAB. So if you have a suspected HAB, then you can actually report that to the Department of Health. And I have the reporting form linked on this slide, which I can also drop in the chat later. They also have an email where you can submit questions. That's habs@pa.gov. And then any health-related questions about HABs, you can also email env.health.concern@pa.gov. So there are opportunities for you to report these. Keep in mind that reporting doesn't necessarily mean that someone is going to help you mitigate or manage that HAB. This is simply just an awareness factor, and it's really important for that to occur because then the Department of Health can be aware if any illnesses pop up in the area, and they could potentially correlate it back to a HAB. Same thing with illnesses for dogs and things like that. So just keep that in mind. But reporting is absolutely critical to gathering more data about this subject. All right, so let's practice identification. So what I want you to do is locate the chat, and what you're going to do is type in yes or no for is this a HAB? Every slide, same question. So find the chat, and this is your first challenge. This picture that's been on every one of my slides. So I'm also going to find the chat. So is this a HAB? Yes or no? Good job. Good job. Okay, I'm seeing yeses. That's great. Yes. So the answer is yes, this is a harmful algal bloom. You can tell based on first of all, the color. It is wildly green, neon green. They're not all going to be green, and I'm going to show you some other examples. But this is a HAB. It's formed out on a large lake, and it's being pushed towards the shoreline. You can see it kind of flowing with the water that way. All right, next one. Is this a HAB? Yes or no? And I have shown this picture already once, so that should give you a hint. All right, all right. I'm seeing lots of yeses. Awesome. Yes, this is a harmful algal bloom. And you can tell by the very historic looking streaks. I mean, this is your quintessential harmful algal bloom that's gathering towards the shore in very slow moving water. All right, this one's a little bit more challenging. Is this a HAB? Yes or no? I'm seeing mixed responses. Maybe. Sometimes the answer is maybe. Good job. All right, so the answer here is yes. This is a harmful algal bloom. You can tell here because this is actually a really up close photo, and you don't see any like granular, grainy looking pieces. So you see streaks in the water instead of like pieces of rice or little fragments or roots or anything like that. So yes, this is a harmful algal bloom, just not as vibrant as the ones I showed you before. All right. Now we talked about a lot of different things. I don't want to I almost gave the answer away. But is this a harmful algal bloom? Yes or no? Nice. Okay. I'm seeing lots of no's. Great. You guys were paying attention. So this is actually algae. It's a filamentous algae. It's too difficult for me to tell if this is Cladophora or maybe another nuisance algae, but you can tell because we've got these very like plant-like structures that are growing on the surface of the water. So it's not paint-like, it's plant-like. All right. Is this a harmful algal bloom? Yes or no? Nice. Nice. You guys are rock stars. Correct. This is actually duckweed, and we talked about duckweed, but we didn't talk about watermeal. Watermeal is also an aquatic plant, but it's just like really, really small. It's much smaller than duckweed. So you can tell because these are really, really tiny grains that you can see, like with your naked eye. So you know it's not a harmful algal bloom. This is a really, really great demonstration photo. But if I go back, if you only had this picture, part of this picture, you might have otherwise. So this is also why it's important to take pictures from multiple different angles and get the full extent. All right, and how about this one? Is this a harmful algal bloom? Yes or no? Good job. Okay. All right. Seeing lots of yeses. Good job. So yes, this is a harmful algal bloom. This is just what it looks like when it's mixed up with some plant material towards the shore. And I've seen them in all kinds of colors when they're towards the shore like this. I've seen them white, I've seen them gray. They can look really, really vibrant, but your telltale sign here is that it's swirly and it's kind of, moving in streaks towards the shoreline. It's not necessarily looking like different like pieces, like I said before, granular or anything like that. All right. Last challenge for you. Is this a HAB? Mostly yeses, some nos. All right, good job. So this one's kind of a trick. Is it pollen? So I love to bring this up because pollen can oftentimes be our greatest mimic of a harmful algal bloom. If you look here on the surface of the water, you can see that it's actually pretty grainy and like granular instead of paint-like. You'd be able to tell really close up, but I did put a question mark here because we don't necessarily have that information. Now, when I tell you, like this photo is one, I'm going to show you another photo. So this is one side of a dock that I was at when I took this photo. And this is both sides of the dock. So when you look at the full extent of where you are, it still could be a HAB or it also could be pollen. We can tell visually under a microscope if it is pollen because it looks completely different than cyanobacteria. However, in cases like these, this is a kind of a trick question. It's better to, when in doubt, stay out. If you don't know, just be cautious. Now, this is at a boat launch, so if you're launching your boat, there's probably nothing wrong with you getting in the water here. There's a dock, so you could step into a boat or possibly, hopefully, dry launch. But if not, you'll probably be okay. But just keep that in mind. That can be very tricky. And I think, to me, both sides of the dock look very different, even though the water is connected underneath. But yeah, pollen can be very tricky. All right. Thank you all for playing. I hope that that was really helpful for you to identify. Let's move into the last component that we'll talk about today, which is preventative action. So there is uh, the main goal, right, would be to control nutrients entering your system. So excess nutrients, primarily nitrogen and phosphorus, are typically the driving forces behind harmful algal blooms. Human activities are what typically increase nutrient levels that fuel bloom growth because nutrients are present in the water in normal amounts. But when humans add things like fertilizer, and I have a bunch of examples on the next slide. When we add to the system, then we can tip the scale in a poor direction, and that can cause harmful algal blooms to have that perfect storm where they can start to grow to excess instead of just in, minute amounts. So the common sources of nutrient pollution that we have here would be, runoff from fertilized lawns and agricultural lands, improperly managed manure, biosolids, livestock, access to waterways. Think like not those things specifically, but like they're contributing nitrogen and phosphorus from their manure and from the biosolids and from the animals directly pooping in water, things like that. So that contributes to the nutrient excess. So if we don't pick up after our pets, that can also contribute nitrogen and phosphorus to the system every time it rains. Failing septic systems and wastewater discharges that are adding too much nitrogen and phosphorus to the system. So phosphorus that has also accumulated in lake sediments over time can be released when there is a low oxygen event. That whole concept is a little bit challenging to describe, but essentially think of it like we call it legacy phosphorus. Phosphorus binds to sediment, and legacy phosphorus exists in sediment, and it's there, for as long as it's been. And it's part of their natural cycle. Now, when a lake experiences a low oxygen event, the phosphorus chemically unbinds from the sediment. So then you have an influx of phosphorus into the system. So that is kind of what happens there. And so it's almost this like this sad like cycle, because the more HAB issues you have in a lake, every time the HABs die off, the bacteria in the water consume oxygen while they eat the HAB material, and then they deplete oxygen, and then you release more phosphorus into the water, and then you have more HABs. So it's just this like endless cycle. So legacy phosphorus is really, really difficult concept to manage. But if we can manage the other ones, we can at least get a good handle on what's going in the water instead of what's already there. So thinking about preventative actions, how do we manage and prevent a lot of this phosphorus and nitrogen from getting into the system? So always apply fertilizers using the 4 R's. So that's right source, right rate, right time, and right place. Maintain your septic systems regularly. Always pick up your pet waste. Limit livestock access to streams and ponds. They really should not be in a stream or pond. So if you need assistance in figuring out a way to keep them out of your stream or pond, let me know, and I can connect you to the professionals at Penn State Extension that do that. You can also install rain gardens and rain barrels to reduce runoff going into the stream or pond near you. And you can plant native vegetation and buffer strips along shorelines in order to prevent the influx of nutrients as well, because the native plants will suck up all those nutrients in the rainwater. And fertilizer is a big issue. Now, I don't want everyone to walk away thinking that this is just a farm issue. This is a human issue. It's an issue applying fertilizers to farms, to our home gardens, and to our lawns. So fertilizer is a tool in the toolbox that we have to use correctly in all cases. So be wise when you fertilize. I love this concept. And I actually had this design created based on the Department of Ag's Be Wise When You Fertilize goals. And so you can see here, you definitely want to follow the label instructions to ensure that you're applying the right amount. Apply the product using a calibrated fertilizer spreader so that you're not over applying to the area. Apply only where you intend to apply. Any fertilizer that lands on impervious surfaces like sidewalks should be swept back onto your lawn. And then try to maintain a 15-foot buffer from waterways. And then here's some don'ts. So if there's heavy rain expected, you don't need to apply your fertilizer. It's all going to wash into the water body or off your lawn, and you've wasted all your product. So it's just a poor practice for your wallet as well. Don't apply if the ground is snow covered or frozen. So believe it or not, this does happen. But if there's ice on the ground or snow on the ground, the fertilizer will not sink into your lawn. And don't use fertilizer as snow or ice melts. So that also, believe it or not, does happen. So also not a good idea. And then avoid applying any fertilizer near water or storm drains or any drainage ditches. So I mentioned that I would make a note about management. And like I said before, I am absolutely not a management expert, but these are some general concepts that I wanted you to take away from today. The first one is that no two bodies of water are alike. And another professional in this field said on a recent webinar that I was moderating, he said, every pond has a personality. And I think that that is so true, just like every lake. So no two bodies of water are alike. So a mitigation concept or a management concept that works for one lake or water body is maybe not going to work for your lake or water body. This is why we always send you to a professional when you ask those types of questions, because we just simply, like me at Pennsylvania Sea Grant, I can't visit everybody's pond and see what your best opportunities are, nor do I have the expertise to do that. And I wouldn't want to steer you in the wrong direction. But some general things to think about to get started if you're thinking about HAB mitigation, reducing nutrient pollution at the source. So a reduction in nutrient pollution is the only way to really get your HAB issue under control. If you don't reduce the influx of nutrients, then you'll continue to have HAB issues. Now, sometimes that's not possible. So you can consider improving water circulation and oxygen levels. The cyanobacteria don't like to be disturbed. They want to sit at the top and they want to photosynthesize and release all their toxins and have a cyanotoxin party. But if you disrupt that behavior by using an oxygenator or aerator or something like that, then sometimes you can break that cycle. And then there's always, emerging innovations coming up. I actually have a slide about emerging innovations and a webinar that's upcoming to share with you in a little bit. And then I did link the Pennsylvania Lake Management Society, or PALMS, here. So they may be able to help connect you to a professional that's local to you, or they might be able to offer you more advice than I can. So be sure to check them out if you're looking for solutions. All right, so this is my more information slide, and I have this whole thing in my text here. I'm just going to drop it in the chat so that you can just copy and paste and click these resources at your own accord. But we've got resources compiled from Sea Grant, Extension, NOAA, Department of Ag, and then I really like this last one, the Department of Health FAQs. It's a really helpful guide. This is the upcoming webinar that I mentioned. Also going to drop this in the chat. So I am on the Great Lakes HABs Collaborative Steering Committee, and I helped them moderate a webinar for the Cleveland Water Alliance in May. That was the first installment. You can view that on YouTube from their website. And then if you want to register for the next installment, the QR code is right there, but you can also go to that website that I dropped in and register there. These are really interesting conversations. They're all about innovations in harmful algal bloom and nutrient management, things that I never even knew about when I started the journey of moderating the first webinar. So just a very interesting conversation, and you might learn a lot of cool things along the way. All right, so I can take some questions now. We have got about 6 minutes. So yeah, Susanna, anything popping into the chat that's of note, or sorry, the Q&A?
Sure. So we got a question. We have a couple here. Our first one is a little bit of a scenario. If a lake is approximately 100 acres, then a HAB is isolated to one end where there is a half-mile separation. What guidance is there for lake usage on the unaffected end?
That is a great question. And I am going to say that that is a personal safety choice. If there's a HAB on one end of the lake and you haven't seen it on the other end, that doesn't mean that it hasn't migrated through there. The conditions can change hourly. So I think you just need to be cautious and it's a personal safety choice. Um, Sometimes though, blooms occur only on one part of the lake because of water conditions and the land structure and how the wind pushes them. So if you've never seen a bloom happen, at the specific spot you're talking about, you might be okay. But I'd still be cautious and check the water. And if there's a really active bloom a half mile away, you might consider just being extra cautious.
Great, thank you. The next one was a bit more of a comment. Going back a little bit to your stick test, they mentioned that benthic filamentous cyanos can be picked up with a stick, and that most of they found some research that indicated that some exposures to antitoxins are due to those benthic mats. I'm guessing she wants to know if you have any comments on that or any
Sure.
elaboration.
Yeah, I'd be interested to see that research. So please feel free to send it to me. And this world of HABs is always changing. So things that I didn't know, like when I built this presentation, maybe have changed and are different now. I do know, like, I only showed you surface scums in the identification photos. And there are a lot of other types of cyanobacteria, like nostoc, that can form like rubbery looking balls. And those will, kind of gather in different places, and those can be toxin producing as well. And yeah, benthic mats, though, I didn't have on my radar. It's something that I've heard about, but not necessarily incorporated into a presentation. Didn't dig into too deep. So I would love to see any photos if you have them. If I can use them in a future presentation, that would be wonderful.
Great, thank you. Yeah, I know that there's a lot of research going into the benthic mats. Generally when I was learning about them, there was a lot of statements saying, there's still a lot of unknowns, and I've definitely seen a lot of efforts, trying to figure them out a little bit more. So she said that she'll send you some things. So
Awesome.
thank you, Amy. Really appreciate it. Um, Gary had a really good question you already answered about the pollen. I've personally ran into that issue before, so that was a really good question to bring up. We have another one that is asking if geese bring algae in to a body of water as they move from one farm or from lake to lake.
So I'm going to say yes, but it's probably not as big of a concern with algal blooms as it would be with something like an aquatic invasive species. So cyanobacteria exist in almost every freshwater body. The geese flying from one water body to another are probably not a risk of spreading harmful algal bloom producers. But my concern there would be, are they bringing anything like an invasive aquatic plant or an invasive or a bacteria that like no like that has not been introduced to that pond yet? Like, so that would be more of my concern than the cyanobacteria. I wouldn't blame it all on the geese in this case.
Oh, those geese, they can cause all kinds of trouble.
They
Uh,
do.
but they're something. I believe we may have time for one more question. And it is about sanitizing boats. What's the best way to sanitize boats and waterways that come from other lakes? So this could be good for invasives as well.
Yeah, absolutely. So same comment, sanitizing your boat from going from one water body to the next, for harmful algal blooms is not really a mitigation tactic that I would promote. something that I didn't mention in my presentation is that the toxins break down over time. So sunlight will break some of them down in a matter of hours, but some of them in a matter of days or weeks. So it really depends on the toxin and the environmental situation. So I wouldn't really worry about a boat transporting the toxins or even the cyanobacteria back and forth. But for general cleaning your boat concepts to avoid spreading aquatic invasive species or really anything from one place to another, you can clean, drain, and dry. So clean your vessel, remove any visible debris, drain all water containing locations, bilge pump, live wells, bait buckets, things like that. And then dry. So dry your boat for at least 5 days. If you can't dry your boat for 5 days, you can use extremely hot water, pressure washer, or soap and water, or like a 10% bleach solution, and run it through all of your locations on your boat that contain water. And give it a good scrub down, dry down after that, and you should be good to go.
Great. So I know that we've reached a little bit after our 1 o'clock, but there were a couple questions about if this presentation will be available to watch after the fact, which um, is definitely a good closing question.
Yeah, absolutely. So I did record the presentation and I can send a recording out to everybody that registered. I don't know if the recording will just be simply from my Zoom link, like where the recordings live in the cloud, or if it will get it on the Sea Grant website for a link to be out. So give me some time to figure that out, but I definitely will get the recording out to everybody. And yeah, if anyone has any questions that didn't get answered today, you are more than welcome to reach out to me. And you can give me a call or shoot me an email. I love answering questions about HABs. So I'm here. And Susanna, thank you so much for moderating today. And Sophia, thank you for maintaining our healthy internet connection.
Very important. Yeah, thank you, Amber. I really appreciate the time that you've taken for this presentation and what you do day to day to educate our public. So thank you.
Sure.
And
Thank
thank you,
you.
everybody.
Thank you all for joining today.
Take care.
Thanks, Amber. I learned a lot, actually, while
Good.
I
I'm so
was here.
glad.
Not just the internet connection. There's a lot of education for me today, too, so it was really nice.
Good. I'm so glad. All right. I'm going to stop the presentation then. Thank you both again.
Okay,
Bye.
take care.
Thank you.